Hello and welcome everyone. Thank you for joining us today for our webinar titled How Expert Data Science Teams Use AutoML to Increase Scalability and Efficiency. My name is Shabar Pula and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Travis Couture is a solutions engineer here at H2O.ai. Before I hand it over to Travis, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We will be happy to answer them towards the end of the webinar. This webinar is being recorded and a copy of the webinar recording and the slide deck will be available after the presentation is over. Without further ado, I'd like to hand it over to Travis.
Thanks, Shabar. I really appreciate it. And just want to thank everybody again for joining the webinar. And we're just going to really dive in today how expert data science teams can make use of AutoML and to really show that it's not meant to replace data scientists, but to really augment or enhance them. So to go ahead and get started, just a little bit of background about H2O in case you're not familiar with us. So we're the open source leader in AI machine learning, and our core mission really is to democratize AI for everybody. So that everybody's company can be an AI company. Really to achieve that mission, we have three separate prongs. So we want to be a trusted partner when we're helping companies to transform their businesses with AI. We want to be an active part of the AI and ML community. And so, we do this through our open source projects as well as some other things. And then we want to have AI for good. So we love to, take AI and help nonprofits or academic institutions as well as different social ventures and things like that. So this is really how we approach our core mission. A little bit of further background about the company itself. So we were actually established in Silicon Valley in 2012. We just completed Series D funding, and a lot of our investors are also our customers, and some of our leading investors are Goldman Sachs and Wells Fargo as well in NVIDIA. And we're really passionate about our customers. So we work very closely with them and we're global across all continents. At the core, our team is really made up of over 10% of the world's Kaggle Grandmasters. And so they're the ones really bringing their bleeding edge expertise into all the different offerings from H2O. So we have some Kaggle Grandmasters that specialize in NLP, others in image processing and things like that to really help the H2O platform really stand out above everything else. Most recently in February, H2O was actually placed as a visionary in 2 of Gartner's Magic Quadrants. So on the left, we were the strongest in completeness of vision for the data science and machine learning Magic Quadrant. And then actually on the right, this is new for 2020, is the cloud AI for developer services. And so H2O AI is a visionary in this Magic Quadrant as well. A little bit of background on some of our customers. So our open source is actually used in almost half of the Fortune 500. And we are in most of the top banks, insurance companies, and healthcare companies as well. We have experience with a lot of different industries as well as use cases. So we're pretty well seasoned in approaching a lot of different business problems across different industries. Now, with that background on H2O behind us, I really want to start to move into the AutoML portion of the talk. So the first thing I want to show here to look at is this is kind of a very high-level top-down view of an AI lifecycle. On the left, you'll typically start with a business user who has some business case or business problem, where AI might be a potential solution. And so this problem will move through to the data engineers and data scientists, where we start looking at things like exploring the data and then moving on towards actually creating a model to solve the business problem. And one thing to keep in mind is, especially as investment in AI grows, is the data scientists would really benefit from fitting into this cycle as seamlessly as possible. There can be some especially large friction points when you actually go to productionize a machine learning model. Because oftentimes the model that's initially created can't always be easily deployed into production. And so there are a lot of different ways that AutoML can actually help out with some of these more tedious or, in the past, frictionful tasks. And really where the core of AutoML comes from and why it's really started to grow is the investment in AI is quite astounding year over year. So from Forrester, there's been a 300% increase in AI spending year over year. And then on Indeed, I'm sure you've all seen the job postings coming up for data scientists or machine learning engineers. So everybody is really hungry to have data scientists and machine learning engineers on their team. But you can't always, scale the data science team up as quickly as the demand rises. So this is kind of where AutoML enters the picture in really two ways. So first, just what are we going to define AutoML as? And it's really the automation of the model development portion of any ML lifecycle. And so really the two goals of this are to, one, lower the barrier of entry for developing effective machine learning models, but two, and more so the focus of this talk, is really to improve the efficiency or time to value of the machine learning model development process. So you have some expert data scientists and you want to use them on as many projects as possible, but they only have so much bandwidth. And so one way to let them really get their expertise into all the business problems possible is to just improve their efficiency. We also have a blog post on our website about the different kinds of AutoML, and there's a link in the slides here that you can certainly visit after the talk. So moving on here, one thing we want to keep in mind as AutoML evolves is we do want to automate as many ML workflow tasks as possible, but we also need to be cognizant that you shouldn't or could not automate every part of the machine learning lifecycle. And so this is kind of where we get into the three generations of AutoML as it's progressed. So in the first generation from 2014 to around 2015, this is where we had, open source libraries coming out. We had different things like feature encoding and hyperparameter tuning, as well as being able to ensemble models and producing model leaderboards. And the second generation here, this is where we move to a little bit more advanced AutoML. And this is where we start to look at things like automatic feature engineering and being able to do things like actually explain the models that we're producing with AutoML. And then in the third generation, which is currently happening, these are things like verticalized solutions, as well as data augmentation and things like custom recipes that you can bring into the AutoML process. One thing that we want to keep in mind as we're talking about this is a very generalized conceptual view of what a machine learning workflow might look like. So you explore your data, you prep your data, you bring it into the actual modeling phase, and then you talk about productionizing the model, as well as documenting it and be able to explain the decisions that the model's making. And we actually have everything color-coded here to show which portions of the machine learning workflow are automated and customizable, or can be controlled, or automated and even extensible, as we'll see here in just a little bit later on the talk. So just to put a face to names here of the different generations of AutoML that we saw earlier, from H2O's perspective, the first generation of AutoML solutions was our open source product. So this is traditional open source as well as sparkling water. The second generation, and we'll really dive down into this a little bit later today, is H2O Driverless AI. And then the third generation, which we're currently working on right now, is called Q. And so this is really going to be focused on operationalizing the AI that the data scientists work so hard to create, and doing it in an easy, intuitive way that it's actually consumable for all users. So with driverless AI, we really want to let you take this platform and do what you want with it, and to be able to not be locked into what AutoML framework has set forward. And we'll see how driverless AI really approaches the ideas of flexibility and extensibility here in just a bit. So with driverless AI, you can really accelerate the time to value, because you're able to automate a lot of what would be considered repetitive or tedious tasks. And then also build upon what driverless AI already has at its core. So we have things like automatic data visualization. We can get fast and accurate results. So a lot of times we actually put driverless AI models in Kaggle competitions, and they actually perform quite well. We also have an excellent MLI Suite, so that's machine learning interpretability. That's useful for a number of different reasons that we'll cover later in the talk as well. And then we actually even address the issue of, I have this awesome model, and now how do I actually take it and deploy it or productionize it? So driverless AI also has a solution for that as well. Here, I just want to go over a little bit of the core architecture of driverless AI. So on the left-hand side, we would pull in our data, and then we'll talk about things like data recipes a little bit later, as well as automatic visualizations. And then we would get into the center here, which is where traditionally data scientists would do a lot of work, which is the actual model building process. So, what type of problem are we working on? Is it regression, classification, maybe image or NLP processing? And then doing things like the feature engineering and hyperparameter optimization, which are things that driverless AI will automate, but give flexibility for the data scientist to control. And then on the right-hand side, we have our MLI, so machine learning interpretability suite, as well as some really cool features and time saving for data scientists, some things like AutoDoc, and then of course, our deployment artifact coming out of driverless, which is called a Mojo. So that's model object optimized, and we'll talk about that a little bit later as well. One last thing I want to cover before we start to dive down into more detail here is the idea or concepts of recipes in driverless AI. So recipes are really you as the expert data scientist bringing your knowledge to the driverless AI framework. And so we'll talk about how you can do things like data recipes, model recipes, feature engineering recipes, and even scoring recipes as well. So these are really awesome features of driverless that allow the expert data scientist to really influence the AutoML process. So before we dive into specifically how an expert data scientist might use driverless for AutoML, let's just see how AutoML is actually useful to expert data science teams as a whole. So as we saw earlier, the investment in AI is really growing dramatically. And it's really not always possible to add more data scientists to the teams for resource reasons. So the question we really have to ask is, okay, how can we maximize their impact, but also make their lives easier, right? We don't want them working 50 hours a day or something. So AutoML is actually this really cool solution that would allow data scientists to automate a lot of the tedious or repetitive tasks. So if you think of things like hyperparameter optimization or model ensembling or things like that, those are things that typically are not necessarily require business intelligence or domain knowledge, but can actually be automated away to a fairly large extent. And doing this actually allows the data science team to focus on the unique core of like whatever business problem they're working on. So these are things like, how do you actually frame the business problem as your machine learning problem? This is really important because how you frame the problem is really going to impact the final outcome. Other things that you might want to focus on are, are we actually using the appropriate data? Do we actually need to pull data in from more resources? Or I've got this model that's working well in training, but on the test data, it's actually doing poorly. So is it the test data is not, is the training data not representative of actually what we're going to see in production? And so what kinds of things do we do to address this? Because really at its core, the goal of data science is to solve problems. And so the different modeling options and things like hyperparameter optimization and machine learning as a whole are really just different approaches to solve whatever problem you're currently facing. So with that in mind, for the general way that AutoML is useful to expert data science teams, let's see how they can specifically leverage driverless AI to bring in their expert knowledge and incorporate it to AutoML itself. So the first thing I want to start out with talking about is you can actually prep your data within driverless AI. One of the challenges you might face is even after you bring data together, there might be some last minute or last mile pre-processing that's required to turn the raw data set into a machine learning data set. And so some things that you might face are maybe there's a very specific customized way of splitting your data that you need to do that. Traditional maybe stratified splitting or just percentage splitting isn't going to cover. There also might be very specific feature interactions that are important. to the machine learning problem just because of your domain knowledge. And so the solution within driverless AI is you can actually manipulate the data once you pulled it in. And there's actually two ways to do this. One is you can actually just use live Python code within driverless AI itself. And two is you can actually create a full data recipe that you can constantly reuse as well. And so these are really two ways that as expert data scientists, if there's a certain way you need to prep your data, driverless AI gives you control over that. And then in the next phase, after we have our data prep and we're actually looking to build our model, driverless AI really provides the flexibility for the expert data scientist to control the model building process. And so one thing that you'll come across pretty common is you're attempting to solve a business problem, and maybe a full-on customized solution isn't necessary or it's not worth the time investment. But you do need some more, fine-grained control over the actual model building process. And so actually how AutoML is building the models. And so one thing that you might want to, consider or think about is maybe I need to manually set the number of folds for cross-validations, or maybe I need specific groupings of data for recommendation systems to make sure all the customers are in the correct splits. Or maybe you just want to control the rate of feature transformation pruning during the actual model building process. And so the solution in driverless AI is actually, we really want to automate, but without handcuffing the data scientists. And so the expert settings panel here actually gives you a ton of control over exactly how the model building process runs. So there's a ton of different options here that, I would really encourage you to dive down into and look at. But really the point of the expert settings is to give the expert data scientists that flexibility to exactly control how the AutoML process is going to run within driverless AI. Kind of the next stage is, we want the driverless AI platform to be extensible and to actually benefit from your team's expertise. And so we do this through bring your own recipe. And so one of the challenges you might face, especially when using, other AutoML platforms, is just the business problem at hand is very complex or niche or unique, and it actually does require a customized domain solution. So maybe you do need to bring in some, really cutting edge or novel algorithms. Maybe there's some very specific feature engineering that needs to be done, or maybe there's even a custom scorer that you need to include to actually optimize the model on. And so this is really where you can leverage your company's IP or secret sauce, if you will, because oftentimes AI is, innovating so fast that you can't always wait for the vendor to update the software. And so driverless AI really handles this in, I think, a fantastic way. And so the solution is to really make driverless AI modular and extensible. And so this is actually done through recipes, and you can actually bring in different algorithms. You can bring in different scores. You can bring in different feature engineering, all hand-coded by the expert data scientists using their domain knowledge and experience to code in Python and then actually import that data import that recipe into driverless AI to then be incorporated in the AutoML process. And during this time, whatever the data scientist has imported will compete with whatever the data scientist allows it to compete with. So you can see it as a survival of the fittest. So driverless AI will bring what it has to the table, and then the expert data scientists can bring their own recipes as well. And then the AutoML within driverless AI will actually explore, what is the best option here, given everything we have to work with. Typically, one thing that you'll want to do after you build a model is you actually want to debug it. And so in driverless AI, this is accomplished through the MLI Suite. And so one of the challenges you'll face as a data scientist is almost never the first model you built is not ready to work at a production level. So you'll need to debug it or, insurance performance across, what you expect the future data to look like, as well as to make sure that the model is operating fairly in some cases where it could have an adverse impact. And so the solution in driverless AI is we have this fantastic MLI suite that features things like local Shapley reasons codes to tell you exactly how each feature really contributed to the prediction outcome for the model, as well as things like sensitivity analysis. So you can run different scenarios and see where the model actually fails and investigate those further. And soon, actually, just like we have with some of the other bring your own recipe options, we're going to have bring your own interpretability. Because oftentimes you will want to interrogate a model in a specific way. And so bringing your own interpretability to the MLI Suite and Driverless AI will be a good way to do that. One thing I do want to mention is we've had pictures here on the left-hand side of the UI view of Driverless, but there's actually also a client for Python and R. And so sometimes as a data scientist, you don't actually want to operate through the GUI, and you'd rather actually take, a more programmatic approach through your language of choice, whether that's Python or R. And so the Driverless AI client allows you to do this, and it's also useful for integrating Driverless AI into other sections of the machine learning lifecycle as well. The final component of AutoML within Driverless is taking the model that the expert data scientist has built, bringing in their own knowledge with custom recipes and fine-tuning the expert settings and getting this really fantastic model at the end, and then handing it off to maybe DevOps or machine learning operation to actually put the model into production. And so Driverless AI produces this model object optimized, or Mojo, which is a super low latency scoring artifact. And it actually includes not only the model, but any feature engineering that Driverless AI also performed. And it's completely portable and self-contained. So you can have the backend be in Java or C++, and then you can, deploy this as a REST server, embed it in an IoT device, different things like that, and even run it in batch or real time. So this is just one of the ways that Driverless AI makes deployment that much easier. So at this point, I actually want to go ahead and move over to Driverless AI itself to go through a demo. So this is a Driverless instance that I actually have running through our provisioning platform here called Puddle. And so this is a datasets page. So there's a lot of different ways to get data to Driverless AI. You can pull it in through Hadoop. You can pull it in from JDBC databases. Any way that you really want to pull data into Driverless, it can be done. So for example here, I've actually pulled in the Lending Club bad loans data set here that we're going to be working with today. And so after I pulled this data set in, maybe one of the first things I want to do with this is do some quick data exploration. So typically, I would do some visualizations and things like that. In Driverless, I can just click on the data set here and I can click visualize. Earlier today, I actually set up this visualization for us. So I'll just dive in here. And what we're seeing are the visualizations that Driverless AI went through the data set and created that it found to be potentially useful to the data scientists. So for example, here in the outliers plot that we have, I can actually come in and I can see, okay, this is on my revolving credit utilization. And I can see I have a couple outliers here that are above 100%. And if I actually click on these dots, I can see exactly what these outliers are. So outlier handling is actually really important for the machine learning workflow. And so now as the expert data scientist, I can decide what to do with these outliers. Are they true data points? Are they errors? How does that handle these? A new addition in Driverless 1.9 is that as a data scientist, maybe I want to actually expand upon the visualizations that I have here. So we can actually add our own graphs as well. So I could select a subtype here. Maybe I want to add a scatter plot and then plot, two variables against each other. I can do that all within Driverless AI and the AutoViz section. So this is really a quick and powerful way to get some quick insight into your data before you begin the model building process. Going back to the datasets page now, this is where I might be interested in after I explore my data and decided, any other pre-processing steps that I might want to do with it to start, considering, starting the model building process. So one thing that you might often do is split the data set. And so in Driverless, this is pretty easy. I can click on the button here and click split. And then I could give a name for train and test. And then I have different ways of actually splitting within Driverless AI. So I could select my target column. So what am I actually predicting the data set here? So in this case, I'm working with bad loan. And then I could actually specify, what do I want my split ratio to be? I also have other options here for splitting, such as a fold column or a time column if I'm dealing with time series. And I could actually save this split here and create a training and test set like I've done earlier. Another thing that I actually mentioned during the slide portion of the presentation is maybe there's a very specific way that you want to split the data set. that's not covered by default. What we could actually do is come into the details section of the data set here and go to modify by recipe. And this is where I could actually upload a data recipe that I've created, or I could come into the live code section here, add my Python code right here, live and driverless. I could hit get preview, and then driverless is going to give me a preview of what my live data recipe looks like after it's run. And then once I'm happy with that, I could actually click save. And then within driverless AI, I would have my data splits here. After I have my data split apart, this is where I'd be interested in maybe actually starting to build a model within driverless. So what I can do is actually come to my training set here, and I can click on the more actions, and I can click predict. I can quickly give the model a name, and then I can select my test data set. So in this case, I'll select loans test. Next, I can select my target column. So what I'm interested in actually predicting here, this is going to be whether or not it's a bad loan. Then driverless AI is going to come back with a lot of additional information here. And there's quite a lot on the screen that we can actually play with. So one thing I can do is to actually come to dropped columns, and I can say, you know, are there any columns maybe that I won't have at prediction time that I actually need to drop here? And I could select these. I can actually come down and apply weight and fold columns individually, and I can manually set it as a classification or regression problem. On the left-hand side here, at the high level, you can see what these settings mean for this particular run of driverless AI. But as an expert data scientist, we'll typically want to dive down past the high-level knob control here, and we'll actually want to dive down into, you know, maybe fine-grained control of the actual AutoML process or experiment process within driverless. So this is where I can actually come into my expert settings, and this is where I can really control every single aspect of the experiment itself. So for example, I can come to things like models, and I can actually control, you know, what's the maximum learning rate for things like GBM models. I could come over to recipes, and this is where I could actually add, you know, maybe some custom code that I wrote. Maybe there's a specific algorithm or something I want to pull in. In this case, let's go ahead and actually pull in a cat boost algorithm recipe here for use in this particular experiment. So if I grab the raw URL from GitHub, I can come to load custom recipe from URL, and I can paste the cat boost recipe into driverless AI and click save. Driverless is going to quickly validate that the recipe can work. And then we'll come back to this screen here. And one thing I want to show really quickly is on the left-hand side, where we see final pipeline right now, we don't see cat boost. So actually, if I go back into expert settings, and I go to recipes, and I select include specific models, I can actually see that I've added the cat boost recipe live while we've been talking here. So now I can actually say, as the expert data scientist, this algorithm that I brought in, I think it's going to be a really good, you know, potential candidate as a final model for this particular business problem. And I can click done, and I can click save. And now on the left-hand side here, driverless AI is actually going to update to show, you know, we're going to include cat boost as part of the experiment building process. In the center here, I could select my score, so what I want to optimize on. And just like the cat boost algorithm I brought in, I can bring in any custom scores I would like as well, although driverless does come featured with quite a few scores built in. After I've set everything up as I'd like as an expert data scientist, I've come into expert settings and I've tweaked everything, you know, maybe specifically how I would like it. I pulled in any, you know, algorithms that I've created that I want to use and selected any scores. I'm actually ready to start the model building process. So I could click launch experiment here, and driverless AI is going to actually start building the model for us. So in just a second here, we're actually going to see some information pop up about how the experiment building process is going. And then on the right-hand side here, we'll actually be able to see different things like the actual score that I'm optimizing on, as well as things like AUC and AUCPR. In the center here, we'll be able to see things like variable importance. So this will be how each feature is in terms of importance for the current iteration of the model building process. And on the left-hand side here, where we see iteration data, this is actually going to be exactly the performance score that we're optimizing on, the current value of it for the current iteration. And the way that driverless AI approaches automatic machine learning is it actually uses a genetic algorithm instead of something like a grid search. So using the genetic algorithm really helps to find the most optimized model and set of hyperparameters. And so on each of these iterations here, we're going to explore a number of different model options as well as a number of different feature options, all while we're engineering features in the background. So you can see here in between these two iterations, we had a metrics jump here. And as I hover over these dots, I can see exactly which features are the most important for the model winning that iteration. So in the most recent iteration here, we have a light GBM with 13 features actually leading the pack. And in the variable importance section here, I can actually hover over these different terms to see exactly what I'm looking at. So for example, this is a transform feature looking at the frequency against the variable home ownership. This model will continue to build in the background, and I can actually look at the different the metrics over here on the right-hand side, but I've actually completed this experiment previously so that we can hop into complete an experiment and see what it really looks like once things are done within driverless AI. So if I click into this completed experiment earlier, I can see how the entire model building process came out, and I can see how the genetic algorithm has actually optimized over time. And I can see that the final model is actually a light GBM with 12 features. And I can see that we have some categorical variable target coding going on here for the different engineers features that I see in the variable importance. On the right-hand side, I can actually see a quick rundown or summary of the experiment. So one thing I just want to highlight really quickly is the actual feature engineering space explored. So driverless AI actually explored 254 different features, but we only selected 12 for the final model. So this is a lot of work that the data scientists didn't necessarily have to do, but could influence by bringing in their own feature engineering. So this is where driverless AI is really augmenting the data scientists to scale. Because now, as the expert data scientist, I can focus on, which feature engineering do I want to do, which algorithms do I want to use to solve this business problem. And I can run multiple of these at once and really, be concerned with the higher level questions rather than doing housekeeping work. Another really nice feature at the end of the model building process is I can actually get a visual representation of what my scoring pipeline looks like. So if I click on visualize scoring pipeline, I can see I have my raw features feeding into an ensemble model of 4 light GBMs. And then this is going to the prediction of whether it's a bad loan or not. But I can actually click into these and I can see exactly which features are being fed to which transformers and then how the model is producing its output to whether it's a bad loan or not. So that's a really nice way to actually see at a high level what the final pipeline looks like, and do the feature transformations actually make sense to you as a data scientist, or is there maybe some more exploration to dive down to in the data to make sure that there's nothing else going on. Another thing that I would like to show before we move on here is this is a gold button here for me called Download AutoReport. So what AutoReport is, and I actually have it open here for us, is that it actually automatically documents the entire process that occurs within driverless AI during the experiment and model building phase. So as a data scientist, you actually don't have to create this documentation yourself anymore. So this is a really great feature of AutoML within driverless, is you don't have to write these reports yourself. So I can actually scroll down and see all the different settings, summary statistics on my different columns. If I continue to scroll down, I can see things like which feature transformations that I explore or use. I have visualizations to see, what are the different relative feature importances and things like that. And so this document is completely automatically generated and is quite extensive, so that you as a data scientist can have this for regulatory compliance or whatever other needs that you might have for documentation. Coming back to driverless AI here, another thing that I would like to touch on is the Mojo portion. So the Mojo is really kind of what we would use to deploy the model. And so this, like we said earlier, is a really low latency scoring artifact. And in terms of just how low the latency is, the Mojo latency for this particular experiment is actually lower than 1/10 of a millisecond. So this is a really fast model that we've built here, which is fantastic when you need to deploy a model at scale. And so you could hand this Mojo off and deploy in any number of ways. We have one-click deploy to cloud. If you want to go to Amazon Lambda, you can take the Mojo out and run it as things like a Hive UDF or different things like that. And all of this is automated. You don't actually have to productionize the model that you've built as a data scientist. It's ready to go to hand off for productionizing as soon as the experiment completes and you're happy with the results. Another part of the model building process that we're really interested in is, after I build this model for the first time, I'm going to be really concerned with, is the model performing the way I expect it to in all cases? So this is where we're really going to move into the MLI Suite here in Driverless AI to debug and interrogate our model. So in the center here in our experiment, I can actually see that I can interpret this model and interrogate it within MLI. I've already done this, so we don't have to wait for it to complete. So if I come into the MLI section here and I click into this interpretation of the bad loans model that I had earlier, I can see that Driverless AI will load up a number of things for us. So in the center here for our DAI model, I can see things like the original feature importance, the transformed feature importance. I can see the original Shapley importance for the features and the transformed Shapley importance for features as well too. I have things like partial dependency plots, which can be really helpful for debugging models. And on the bottom here, I have things like disparate impact analysis and sensitivity analysis. So sensitivity analysis, for example, is a really great way to come in and bring your knowledge as the expert data scientist to say, depending on the business problem I'm working on, maybe the false negative predictions are actually, really impactful to the bottom line for the business. So I can actually filter out only the false negative predictions, and I can see, exactly the predicted values that the model is producing. I can even come in and change things. Let's say, for example, I want to have a relative change to DTI, so debt to income ratio, and I want to increase that by 5%. So now I've increased this particular feature by whatever amount. I've changed it by whatever amount. And now we're going to actually generate this data based on this change, and I can rescore within Driverless AI. And once the rescoring is completed, I can actually see how my model reacts to these different scenarios. So I can see, are there any corner cases or edge cases where my model is failing? And then dive down with my knowledge as an expert data scientist and the domain knowledge for the business problem and say, why might this be failing, or what can we do to actually address these failures? And so this is done for you as a data scientist within Driverless, and you really get to focus on really the important business problems rather than creating all of this from scratch. If I come back out to things like disparate impact analysis, these are things that I can actually use to make sure that my model is performing fairly. So, do I have any protected classes in my data set that I need to make sure that the model isn't adversely impacting with its predictions? So I have, different things like being able to view, true positive rates, adverse impacts, as well as confusion matrices, all available to me within Driverless AI. And I can use this data that's given in front of me to ask the questions and then decide how to address them. I also have things like surrogate models within Driverless AI. So I have options for things like K-Lime, so I can generate K-Lime reason codes, as well as come in here and look at individual rows. So I could search and see, how does row number 5 actually fall within the K-Lime prediction here and the actual prediction value for bad loan. I also have other options such as a surrogate decision tree. So this is really good for if you're dealing with, how explainable is my model. I can see how well a surrogate decision tree approximates it, and I can also download this as well. I also have things like the surrogate random forest feature importance and things like that. I also have a diagnostics section here within Driverless AI that you can actually use. Let's say, for example, I want to diagnose a model on a completely new data set that it's never seen before. Maybe, you want to make sure that it's outside of your MLI suite. You want to make sure that the model is performing as expected on an entirely new data set. So I could actually come in here and select a new data set that I want, or a new model that I want to use, and then select my new test data set here. and then I could run a diagnostic actually on that and get the prediction values back and see that everything is lining up appropriately. So now I just want to hop back over here to the slides, and we'll go ahead and start to move in towards more of the Q&A section. But before we get to that, one thing I want to point out is we actually have a learning center for not just driverless AI, but all of the different offerings that H2O has. And so this is called H2O Aquarium. And so if you're really interested in that, I encourage you to visit there to explore some of the different tutorials and lessons that we have. We also have other ways to get started. So you can actually sign up for a free test drive for driverless AI. So you can also come to other meetups and things like that. And then, of course, come to additional webinars. This is kind of where I just want to stop and see if there are any questions on the line. I like to leave about 15 or 20 minutes for questions just in case, you know, there's some more complicated ones that we'd like to answer.
Thank you, Travis. We do have some questions coming through in the chat room, and we'll try to get through all of them. And also feel free to answer, ask any questions in the chat room. One that's been asked a couple of times is driverless AI free or open source like sparkling water?
That's a great question. So driverless AI is our enterprise offering. And so we do have free trials for driverless AI that you can work with. You can also go into Aquarium and play around with driverless AI a little bit. But it is not an open source product like sparkling water or traditional H2O open source. So, I mean, if you're interested in, you know, maybe test driving driverless AI, you could certainly, you know, look into a trial. But I would also encourage you to reach out to us because, you know, even if it's not myself, we would love to kind of talk to you to see, you know, where you maybe see yourself using driverless AI, because we would really love to work with you on whatever problem you're facing, because it's really interesting to us, and we love helping, you know, data scientists succeed with driverless AI. Thanks for that question.
Perfect. You did touch on recipes, but somebody asked, how do we create recipes for driverless AI?
That's a good question too. So we saw earlier in the presentation that there is some Python code. And there's actually right now, if I come to GitHub, there's an entire repo basically dedicated to driverless AI recipes that anybody can use or access. So if I scroll down here, I can see that there's a number of different recipes already available to me to use. But if I'm interested in creating a novel recipe, we actually have a how to write a recipe section here. And this goes into all the different steps of, you know, what if I want to write a transformer recipe and different things like that. So that's available on this GitHub, which is also linked in the presentation. Thank you for that question.
Okay. What types of situations where you would suggest driverless AI over Q or Q app?
Right. So driverless AI is really an excellent way for you to accelerate the time to value for whatever problem you're working on. And so let's say that you need to react to a changing situation very quickly, and you need to bring in your data as quickly as possible and build out a model. Driverless AI is really what's going to do that. The more so focus of Q is to create, you know, entire AI applications. So you could build vertical solutions around the driverless AI model that you created, whether that be things for, you know, how do we handle anti-money laundering, or in this case, actually in Q, we do have a lending scenario application as well. So driverless AI really serves to build the core model itself, and Q can actually take that core model and you can create an entire custom app around it. Or Q also has some offerings for, you know, pre-created vertical solutions such as anti-money laundering or you know, predicting lending scenario outcomes as well. So those are kind of how Q and driverless operate differently, but also operate together. Because you can certainly take a model that the expert data scientist has created in driverless AI and then incorporate that into your own custom Q app. Because you can actually develop Q apps as well with the Q API, which if you're interested in that, I would also encourage you to reach out because I think that's also really interesting as well. Thanks for the question.
Great. Another question is, how is misuse of the open sourcing of AI models and products handled by H2O?
I'm sorry, you broke up a little bit there. Can you repeat that?
Sure. How is the misuse of the open sourcing of AI models or products handled by H2O?
So I think what we're asking maybe about how I'm understanding the question is we've created this AutoML, and a lot of people can create models now, and they might not always be the best or most appropriate models. And so one thing that you can do to address that is actually the interpretability or explainability of AI or fairness of AI. There's a lot of different terms that revolve around that. So you would build this model, and then you would actually want to make sure that the model is doing what it's supposed to be doing. One of the best ways to do that is through MLI, or machine learning interpretability. And within driverless AI, that's actually covered very extensively to make sure that the AutoML model that you've created isn't just some black box model, that you can actually go in and give reasons as to why the model made its prediction. So that way these models aren't misused for the business problem that they're attempting to solve. So that's actually a really good question, and there are actually some, entire talks dedicated to that. I would encourage you to go search and watch, because they're really interesting as well. So thanks for that question.
Yes, correct. That's true. Perfect. Regarding how AutoML adjusts to the changing data scenarios, does it adjust the model itself, or the data scientist has to interfere if there is a prediction that goes wrong?
So if there's, are we talking, so there's two different scenarios. Is the prediction going wrong during training, or are we getting wrong predictions during production? Because it's actually I think two different issues. During training, it might actually be an issue with, maybe your data is actually representative of what of the problem that you're trying to answer. And so maybe you do need to pull in additional data. In these cases, maybe when you go into sensitivity analysis and you're looking at, the misclassified predictions, maybe that investigation there actually tells you why the model is maybe making those predictions, and then you as a data scientist can address those, and however that might be. Maybe you do actually need to pull in more data, or maybe you realize that there's a feature interaction that's super important that you need to ensure is in the model. Or maybe it is just, maybe fine-tuning some of the expert settings. So that's something that the data scientist using driverless AI certainly has control over. On the other side is, if this model is in production and it's been doing okay, and then you start seeing, a degradation in performance, or a bunch of wrong predictions coming out, this is actually probably a sign that maybe your data has actually shifted in production. So for example, I'm sure, almost all the models running actually saw this, with the changes from COVID-19 that happened. There's a fundamental shift in the incoming data. And so the model that was built on, data that's not what it's seeing is, of course, not going to perform properly. And so this is a different issue of, you actually need to retrain the model on this new data that's coming in, or even, maybe the features that are important to the business problem that you're trying to solve have changed, just because the business landscapes has changed over time. So there's a difference between if the problem's happening in training and in production, and then there's different ways to address that. And the data scientist certainly has control over both, but you just need to make sure that is it in training or is it in production? Thank you for the question.
Thank you for the clarification on that, Travis. How does driverless AI work with Hadoop? Data reside in Hadoop system as Hive or Couture tables?
Yeah, so you can actually pull in data directly from HDFS. And then if we're talking about, if you want to deploy the models, there's a bunch of different deployment templates that we have for Mojos. So for example, you can deploy in Hive as a UDF. If there's a specific deployment option or usage that you have in mind that's maybe a little bit more specific, I would encourage you maybe to email us or reach out, and maybe we can just set up a talk and talk about your specific need. Because chances are, somebody has already done it before, but it's always good to clarify those things when you're actually looking to deploy the model. That's a good question though, because deployment is such a huge part of the actual machine learning lifecycle.
You mentioned Mojo. Can you explain a Mojo? A couple people were asking.
Yeah, so let me actually go back to the slide really quick because it will help to have the visual. So the Mojo is really what it stands for is the model object optimized. And there's really two components to this. So there's the model API or the key to the Mojo, if you will, that really is what the, whatever you're requesting against will hit. And then you have the actual Mojo runtime, which is where you have your, your actual model and, your feature transformations and things like that. As a whole, what the Mojo really is it's a self-contained scoring artifact. So the model that we built in driverless AI, it has all this feature engineering. It might be an ensemble model, and we want to take this entire thing, not just the model part, not just the ensemble part, but also the feature transformations that driverless AI found for us or that we brought in through custom recipes and deploy that whole thing into production, right? We don't want to deploy individually or only a piece of it. We need the whole thing. And so the Mojo wraps all of that into a single scoring artifact or package with the added benefit of the super low latency. So earlier when we built our bad loan model, we saw the scoring latency was actually less than a tenth of a millisecond, which is super impressive. And so we have this completely self-isolated scoring artifact that runs super fast that we can port anywhere because the runtime only really requires that you have Java or, if you're using maybe TensorFlow models, C++ as well. And so you can take these Mojos and move them anywhere you need to deploy them and run them in, either in batch or real time. So it can be setting in a REST server, having real-time requests come to it, sending back decisions, to your customers and maybe your mobile app or something like that. Or maybe it runs in batch, or maybe it runs on an IoT edge device or something like that. And so that's really what the Mojo is a way to take all the hard work that you've done in driverless and easily productionize it. So that's really the core of the Mojo. That's a good question. And, sometimes deployment and Mojos in general kind of deserve their own talk. So if you have additional questions or interest in that, please feel free to email me or contact H2O in general. Thank you.
Perfect. Thank you. We do get that question sometimes on these webinars, so it's great that you explained that. What is the advantage of H2O Driverless AI versus Google Cloud AutoML? Google Cloud AutoML table.
Yeah, so that's a great question. So without getting too much to a dive down in comparison and really just stating some core fundamental differences, one of the best things about driverless AI models is actually going back to this Mojo, is I've created this model, and with the Mojo, I have the option to deploy anywhere I want to deploy. It doesn't matter. With some of the cloud vendors and, for example, like GCP, AutoML, and things like that, your deployment options are a lot more limited. Typically, you have to deploy in that cloud vendor's cloud using their services. But maybe sometimes that's not what you want. Maybe you actually want to take these models that you built and deploy them on edge devices that maybe you don't have outside internet connection or aren't going to be serving real-time data. And there's a bunch of different scenarios where you might not need to deploy in the cloud and you need a more customized deployment solution. And that's where one of the places where driverless AI excels. Another place that we really excel is actually the custom recipe department. So the extensibility and flexibility of driverless AI is, I think, significantly broader than what you would find in a lot of other AutoML solutions. So it really enables the expert data scientists to bring what they have to the table and use driverless AI's framework to automate away, all the other stuff that they might not necessarily want to, work on themselves, such as the hyperparameter optimization. So if you created this really cool model, or you're bringing in a cutting edge algorithm and you bring that to driverless AI, that's not really, as easily possible with something, running on like AutoML for tables and Google Cloud or something like that. And then our MLI suite is typically much more advanced as well, which is really important for not only debugging the model, but then if you're in a regulated industry, let's say, for example, you're in banking or insurance, and you make a credit decision or you make a policy decision, you need to be able to say why your model made that prediction exactly. And so having the MLI suite available to you from driverless AI lets you, bring things back super easily, like Shapley codes for global and local and things like that as well. And the MLI Suite driverless is just typically a lot more mature than you would see in some of the other AutoML solutions. We could really drill down pretty deeply into the differences. So if there's anything specific that you might have in mind, like, maybe GCP does this, how does driverless AI approach this? Or GCP can't do this, can driverless AI do this? I would really encourage you to reach out and ask about that as well too, because I think it is a worthwhile comparison, and we actually love to show how we're different and more beneficial in most ways. So thank you for the question.
Perfect. Another question is, if we retrain the models, will it keep a snapshot of previous runs to compare both the runs or both models?
So that's a good question. So actually, let me hop back over to driverless AI really quickly and go back to experience. So there's a couple different things that you can do. One thing that you can do is you can actually come here and you can drop down. You can see that you can actually create a new model with the same parameters. So let's say I want to keep everything exactly the same, except maybe I want to explore the space differently again. I could create a completely new experiment. Or let's say, for example, that I actually do want to retrain the exact same model with the feature engineering and everything. I can actually just come here to retrain final pipeline and select that as well. In terms of versioning of the models, you have, so let me actually click this here as well, and I'll click launch experiment. And this will actually be noted in the logs here within driverless AI as well. So that's something that's tracked. You can also have an entire project dedicated to an entire business problem that you can organize your experiments into, to organize, maybe you have different versions where it's not the exact same pipeline. Maybe you've actually brought in new features, and the new model actually includes those new features and is going to supersede and replace the old model that had the older set of features, but you still want to organize them together so that you have that visibility and tracking. So you can organize these together into a project as well. So I could say demo, and then I could actually come in here and I could link my different experiments related to whatever demo it might be. So I would have that option available as well. If there's maybe something more specific about model versioning that I didn't touch on here, I would say reach out because model lineage and things like that are actually, can be really important, especially at an enterprise level. So if I didn't answer your question here, please feel free to email me or H2O in general. But thank you for asking it.
Great, and it looks like we have time for one more question. How do you ensure that AutoML produces explainable and interpretable models that can pass regulatory model validation requirements?
Yeah, so that's a good question. There are a couple different ways to do that. One is we actually provide, so let me actually create a new experiment here. As a data scientist, you can come into expert settings, I can come to recipes, and I can go to include specific models. And maybe I only want to include a decision tree and a GLM, so generalized linear model, for regulatory reasons, right? I know I need the model to be super explainable, and I don't want to do it with the knob settings in driverless AI that we see on the experiment launch screen. I actually want to come in here as the expert data scientist and say, I only want to use these models because I know they're explainable. On the other side of that is after you create, maybe you do limit the models, or maybe you have a little bit more flexibility and you can include things like, XGBoost or late GBMs, but you still need to be able to provide, the reasons as to why the model's making the decision. That's where we would come back to MLI here. We could actually generate, do I need, the K-line reason code, or even better, I'll give the Shapley reason code. And then I also have the option of the disparate impact analysis. So I can make sure that the model isn't treating any classes unfairly or anything like that. So MLI is a great way to make sure that your model is up to regulatory compliance for different areas, and that you can actually, take the model that you've created and productionize it. Because if it doesn't meet those regulatory requirements, no matter how good the model is, you're not going to be able to put it in production. So MLI is a great way to ensure this, along with AutoDoc too as well. So this is another great way to track different things for regulatory compliances as well. So that was a good question. Thank you.
Well, perfect. I think that's all the time that we have today. So thank you, Travis, for taking the time and doing a fantastic presentation. And I'd like to say thank you to everyone who joined us and sent us those great questions. The presentation slides and the recording will be made available after the presentation is over. Have a great rest of the day, everyone.
Yep, thanks for coming, everybody. See you next time.